Okay, next up we have ZAP Cloud Manufacturing, and presenting for ZAP is John Dower. All right, welcome to the stage. Go ahead.
Hello, TechCrunch. Just imagine you could go from design, manufacturing, distribution instantly. What an advantage would you have? When time to market is one of the most important things when you're trying to beat your competition. Hi, my name is John. I'm the CEO and co-founder of ZAP, the world's first cloud manufacturing platform. Now, you may ask yourself, why would you want to move manufacturing to the cloud? Well, enterprises go through this thing called rapid prototyping and advanced manufacturing. On one side, they have all these machines, and all these machines have different software and operators. And on the other side, you have designers. And all day, they go back and forth with Excel files, spreadsheets, file shares. It's a very cumbersome process, and we've confirmed this with many Fortune 500s. So you want to go from an idea to a real object instantly. So first, you start with your 3D design. Then you have to learn all the different software for your 3D printers, CNC, water jets. Why? They're all in 3D. Then you usually have to walk up to these machines and manually operate them. There has to be a better way. So compounding this issue is manufacturing is decentralizing. Now, you don't have engineers in one location. You have multiple factories and engineers in different locations. So how do you deal with this? Well, luckily, about 4 years ago, with my co-founder Anton, who was doing his PhD in cloud computing and robotics in Estonia, together with 10 engineers, we developed the world's first 3D printing operating system, where we designed a system where it connected 3D printers to the cloud so designers could instantly print. And we produced over 75,000 parts in 100 countries. It unlocked innovation at a scale we've never seen before. Students at Duke in the last 2 months produced over 10 companies and took them to market instantly. So for TechCrunch Disrupt, we're announcing our manufacturing platform called ZAP. And our vision is one-click manufacturing. And it's not just 3D printers, it's connecting all these machines and workflows in the cloud, anytime, anywhere. So let's take a quick sneak peek of demo. Let's switch to demo. So let's say I'm going to build a prototype drone. I've got an idea for a drone. So here I've got the drone design, I've uploaded it. And instead of having to deal with all the different software, I can instantly click on the different manufacturers for many, many different machines and instantly render it. So now my designers, instead of having to go back and forth, can instantly see how that design is going to be built. And this is happening in the cloud real time. This works on Android, iPhone, pretty much anything with a web browser. So if I want to produce this part, I then can look at my field of machines that are ready to accept this job real time. So in this case, I'm going to find a facility. Let's see here. Okay. Let's go to Japan. So I'm going to live view into that machine. It's ready to go. I'm going to hit print. Now, real time, our system is taking over that machine, and these machines usually use SD cards and USB sticks. So we've got a client that runs in what we call the fog, which connects to the cloud and takes control of the machine. So that's printing right now. Now, it's not just for 3D printing. CNC, water jets all use the same technology. Why do you need different software? So now I've got, okay, so you can do that. And it's also, we can actually print these parts anywhere in the world. So let's say I want to print it on a Mars space station. Obviously, Oscar has better things to do than hang around and manufacture. So I can log into the machine he's just dropped off. And from the ground station, I can go ahead and engage in that machine remotely. So this is ZAP allowing you to connect to anywhere, anytime. Now, it's not just 3D printers. We also have these 2 robotic arms that are arc welding. We have water jets, and you can see I'm already producing those drones real time. So I've got entire control of all my factory with 1 click. Now, it's not just about controlling the robots, it's also controlling the workflow, the assembly. So in this assembly, on the left or the right on your screen, I've got my CAD designs, I've got my manufacturing machines. I can instantly, quickly change the workflows. I can log in and instantly see the workflow, and everything I'm changing, all the assembly workers see as well. Very easy. Now, if I want to duplicate the factory, this is my San Francisco factory. I click duplicate, and now I've got another factory. I can change the location, and let's make this in Japan. So my guys in Japan, once the parts print, they know what to do with them. So that's a quick preview of ZAP. and let's switch back to the slides. So how do we monetize on this value? Well, so far we charge $200K per site license, and we've already signed up 2 large enterprises, Ford and Cisco. They're looking to be more efficient as they scale worldwide. So that's ZAP, taking an idea to real object instantly, anytime, anywhere. And we encourage more enterprises to join our pilot and see the manufacturing of the future.
Awesome. You finished ahead of time, and you brought an astronaut on stage. That is pretty freaking amazing. All right, question.
Let me jump in here first.
Sure.
I think it's more of an obvious question. Your company's based on an underlying assumption that there are a lot of machines that are internet-enabled. How do you think about the foundational aspect of it? How fast will that world really turn before you actually become a big company? And how do you think of that, about the market size?
Yeah, I think actually being directly connected to the machine is about 5% of the problem. 95% is the workflow. So everyone has different files that they share around in SharePoints, Excels. There's no clear utilization. So even if it's a manually operated machine, which most of them still will be, you want to be able to queue up jobs. So you should be able to queue up the jobs in a consistent way to the manual machines as well as the automated machines. So queuing up those jobs and being able to easily do it through a web browser, letting your designers see what those designs will look like. Because what happens now is they send a design to someone else. They say, hey, you can't manufacture it like this. They go back and forth. And it's like, you know, what happens in car manufacturing. They have a really nice, sexy car design, and by the time they're going back and forth, they realize the machines can only do so much. It comes back looking like pretty much every other car. So it's how do I reduce that latency? And that's what happened at Duke. We have over now 500 students, and this year there's going to be 2,000 students on 36 printers. So the idea is that they can prepare their own designs. The same 3 administrators that barely struggled, you know, supporting 10 printers now support 2,000 students and 36 machines. So the overhead goes down. So it's about how do you prepare your designs ahead of time. And these advanced manufacturing machines will be the way things are manufactured in the future. You know, of course, we have classical manufacturing. And so how do you get them those tools in a web browser? It should work on Android, iPhone, pretty much anything. So it reduces that latency. In the case that you need to queue it up to a manual machine, it's consistent. And for an enterprise, most enterprises are emailing designs, which is not very secure. So also there's an IP security issue. You know, database-driven systems are inherently more secure because you're not having file-based USB, you know, emails. People are emailing designs to third parties. So maybe you don't have a titanium printer, like, you know. And so you have to send that through email. They have another Excel file. You don't know the utilization rate. You've got this rapid manufacturing facility. So it's how do we get this to zero latency? So 95% is the workflow problem in enterprise, and 5% is the connectivity. But we're finding that as we start owning the workflow, the manufacturers want to work with us.
Got it.
Great demo. Really liked it. And you said that you're charging $200,000 per site. How did you come up with that pricing? And then my second question, it seems that beyond the workflow, you're also getting into manufacturing. So how can you ensure that the quality of that manufacturer matches the quality of your workflow? And why not connect to a marketplace, given that you don't have full control of the manufacturing?
So I think there were some assumptions about marketplaces. There was consistency of controls, even a CNC machine, depending on who's operating it. So the first problem is, imagine you have a bunch of computers in your office. Those things need to be on a network. There needs to be a process to control them. So it's how do you get your own house in order? You have all this equipment. I think in the future, when machines can have consistent quality, so even if you buy the same metal 3D printer, for example, or CNC mill, those things are hot-rodded by GE and other manufacturers to work for them, right, the way they want it to. So I think it's going to be a little bit further in the future where everything is consistent, but in the beginning, it's how inside my enterprise do I manage these resources? I can't just have people working in underground bunkers and use physical controls and body checks to make sure they're not walking with, you know, SD cards. So it's IP digital controls within the enterprise, and that's kind of the first step.
And on the pricing?
Yep.
Does that include the manufacturing itself, or is this just for
No, it's just it's a SaaS product, private cloud, and so enterprises can manage these IP and machines and people and designs within. So we're starting with the $200K per site license because it definitely requires more than one human of value to operate. Definitely security-wise, it's there. So that's our pilot pricing. You know, we probably will go up from there. And keep in mind, a company like Cisco or Ford have multiple sites. So they instantly can see the value when they can real-time create reports, They can manage IP. It's, we've got access controls, who downloaded it, who uploaded it in case it comes out of the system. So, the common things that happen with databases and, moving to the cloud with data warehouses is going to happen to manufacturing as well.
Aparna?
Yeah, I love the magical and tidy solution you have, but one reaction I have is the same reaction I have when folks talk about to-do list apps. Right? It's beautiful, it's perfect, but people have their own existing workflows. They have their own ways of doing things, however inefficient they are, however they are subjected to all the things that you talked about. So can you say more about how you're thinking about
Yeah,
changing
so I think it kind of reminds me of computers long ago. It was okay when it was a limited resource and 7 or 10 people worked on it. But once you have like 4,000 designers at Ford that need access to those so they can iterate their product quicker, it becomes a bottleneck. And so you would have to hire many more people to take that workflow manual. So it's becoming the case that advanced manufacturing is taking over, prototyping is becoming more important, and getting the product to market. So these machines are growing in sizes. People don't just have 1 or 2 of these machines, they have tens. And you saw like GE, they've got like now a whole factory full of machines. So I think that's what's changing, is these robots that can build in quick time are coming to market, and you need to be able to manage this and connect them to your designers with lower latency.
Cool. Well, I think we're out of time. So one last round of applause for ZAP.
Thank you.